Hi, welcome. Uh, we just have a couple people on the call right now, so we're just going to give a few minutes for others to join. Um, if you do have a question for this morning, I feel free to just type it into that question box, and we'll make sure we get to that today. Or if there's any topics that you want to make sure we cover today, you can let me know that as well. Welcome. If you've just joined us, we're giving a few more minutes. We have a very small group so far, so we're just going to give a few minutes for others to join. If you have a question that you want to talk about this morning, feel free to type that into the poll box. Or if there's just a particular topic, either from Unit 4 or from the course that you would like to talk about this morning, you can let me know that as well. All right. Well, thank you so much, everyone, for joining us. Good morning or good afternoon. I really appreciate everyone taking the time to be with us today. If you just joined us, and you have any questions that you want to talk about today, either from Unit 4 or earlier in the course, feel free to write those in the poll box that shows up on your screen. You can also feel free to put them in the chat as well if that's easier. But this is just a good way for us to collect any questions you might have and to make sure that we get to talk about those today. Um, these office hours sessions, really, my hope is that we do get to cover any questions that you have or any challenges you might be having, um, and get to talk, yeah, just do the topics that you'd like to cover. So please do let me know if you have a question or just the general topic from the course that you'd like to cover in more detail today. As you know, we always have some questions and review slides, some polls that we can go through, and I hope those are helpful. But again, if we spent the whole time talking through your questions, that would be a perfectly good way to use the session as well. Um, so yes, please let me know. Um, yes, Ong, I see your hand up.
Oh, hello, Jessica. My name is Al, introducing you because this is my first time joining this Zoom meeting. So will be last because I've completed all the units and received certificate already. But I'm joining happily with all of you, even though this is small, but I'm happy. In my place, by the way, in my place, this is evening in Myanmar. So good evening.
Okay.
So I have a question. It's about tight angle. So based on different location, tight angle will be different, right?
Yes, yes. The angle of your array, yes, will be different. I'm going to note that down, and that's something we're going to talk about today. But I'm so glad you're joining us. Congratulations on completing the course. But I'm glad that you were able to join us this morning, even though you completed all the material.
Yeah.
So
For organizing this course. Thank you.
yeah, and thank you for letting me know of that question. I am planning, yes, we'll go through that today to talk about different angles and what our recommendations are and how you can decide what that angle should be. Awesome. Any other questions to start the day or just topics you'd like to cover? Again, it's a small group, so feel free to unmute and speak up, or the chat is always good if that's easier for you. I'm going to leave the poll box up for just a few minutes. So in case you do have a question you want to drop in there, you can do that. We'll just go through some of the introduction, and I'll leave that up for you. Okay, so welcome to office hours. I know some of you have been able to join us in previous weeks, and for some of you, this is your first office hour. So welcome. We're really glad that you could join us today. Um, so this is a time for participation and to get to discuss some of these course topics as a group. So please feel free to ask questions. Also feel free to answer questions. I think we've said this before, but everybody in the room today has different experience. Some of you have more experience than I do. And so you're going to have different answers to some of these questions because some of these answers will depend on your context and the situation you're facing. So please, if you have a perspective to share on somebody's question, please feel free to share that. It's not just my answers that matter here. I will always answer questions the best that I can based on my experience, but I'd love to hear from others as well. And so you can also raise your hand if you want to speak up and contribute. That'll just let me know that you have something you'd like to say, so that's helpful. Um, and then you can type in the chat. We'll have some polls. I would love if you would participate in those. Yeah, again, this time to ask questions, share with each other. Okay, so quick check on where we are in the course. So this is week 4, and we've started unit 4, which is the final unit of the course, getting into the solar array design, which is probably what most of us have been waiting for. And we are going to give 2 weeks for this unit because it is a lot of new material for most of us. Even if we are familiar with designing water projects, that solar component might be new. And so just to be able to give you time to go through that, we've given 2 weeks. So next week we'll continue through on the same unit. So you'll have some more time to finish that. So in the call today, we'll kind of go through a review of the first half of Unit 4, and then next week we'll round out the last half of the unit. I'm going to go back just a little bit to see if there are any questions related to Unit 3. So I'm going to go ahead and end our poll. If you still had a question you'd like to share, feel free again to put it in the chat or to raise your hand at any point in the call. So we went through this one last week, but for those who maybe weren't able to be here, I'm just going to launch this quick poll as kind of a warm up for the day. Okay, so why is understanding pump power requirements so important? Pull back to Unit 3 for a little bit to start us off today. Yeah, so a lot of votes for it helps us size the solar array. Um, that's right. That's why we need to make sure that we are understanding all the power requirements of the pump or maybe the inverter that we're selecting so that we can make sure that as we're designing the solar array, it is large enough and also that certain things like voltage and current are in the right ranges, right? So um, Zarahoon, I see your hand up.
Okay, good afternoon, everyone. Good morning, Jessica. I have a single question here. When we plot the system curve in the course material, of course, a system curve is a curve representing, or it's plotted head versus discharge or flow. But there are two types of curves. The first one is a system curve. The other one is a pump curve. And the pump curve is produced by the manufacturer usually by using testing conditions in the laboratory when they manufacture the pump. But during the course, in order to get the pump duty point or operating point, we plotted a system curve taking the head and discharges from the pump curve. But actually, it is not the case. The system curve is plotted from the actual or real-time pump test data taken from the field. That's why it is called the system curve. The discharge and the head, or the flow and the head, should be taken from the pump test on the field, not from the pump curve from the factory. So can you maybe explain this one? Thank you.
Yes, yes, that's a great clarification. Yes, there are two curves that we are looking at. The pump curve, as you said, is from the manufacturer, and they get that data from their tests. And then, yes, you're right. The system curve is taken based on the system that we're designing. And so, what we're doing when we create a system curve is we are calculating the TDH, the total dynamic head, for our system at different flow rates. We don't go into detail on how we've done that in the course, just honestly to pare down a little bit on how much we're trying to throw at students. But yes, so what we're doing when we create the system curve is, especially in your design tool, we are calculating the TDH at a range of flows. We're just matching that range of flows up to what the pump we've selected can do, just to make sure that we've selected that range that will intersect the pump curve. So I can see how that would be confusing that we've maybe pulled the data from the pump curve, but what we're actually doing is we're just selecting some of the flow rates that we find on the curve that we've chosen. And then what the sheet is doing, the design tool, is calculating the TDH for those corresponding flows. And so that way we make sure that we get the system curve overlapping the pump curve so that we can find our operating point. Does that help?
Yes, Jessica. For me, and I have an experience on this, so I understand. Maybe if there are some people, maybe if they don't have a field experience on this one, it will be confusing. Maybe they will use the pump curve or the pump curve data from the manufacturer to draw the system curve. So it is always better to put some kind of explanation on the course material. There is no explanation put on the course material. So this is just a comment. But I understand your point. You don't have to get into the details within this short time frame. I understand. To add one comment, honestly, I find this course the most practical online course I have ever taken in the past. I took different technical online courses, but this is the most practical one. So I really want to appreciate the Global Water Center on this one. Maybe if it is possible or if it is available, I don't know. In order to I advise you to make this course a bit wider, like not only focused on solar. Maybe if you can make it a hybrid one, just sizing generator, sizing the grid, and it is going to be like really nice if you can widen this course. This is a comment for the course. Thank you.
Yeah, thank you for that feedback. It's really helpful. One, I'm really glad that the course has been very practical for you. That's great to hear. I'm so happy about that. And I really appreciate the feedback too. We can definitely add a note about the system curves for others who aren't as familiar with them. If anybody has questions on the call today, or if you're watching it back and you have questions about the system curve or how we created that or how we're using it in the design tool, please reach out. I'd be happy to answer those. And again, to clarify that portion of the course. And then, yes, we've had a couple different people specifically ask for more information on hybrid systems and how to size those. And so that's something that we can consider maybe either adding or having a supplement on. I'll have to look and see if I have any good resources that I could send out to all of you now on adding hybrid into this as well. And maybe that's something that we can add in the future. I appreciate that. Okay, so any other questions related to Unit 3? Or again, any questions in general? We'd be happy to guide this discussion based on any questions or comments that you might have. But we'll jump into Unit 4 here in a minute if there's nothing. All right, and I'm going to pull up, we did have a couple of questions come in to our poll, so I'm going to pull those up real quick and make sure we get those in today. So we did have one question about how to size pumps and how to do that with the solar array. So we'll talk through that a little bit today. I just want to clarify the question though. So in this course, we are sizing a pump based on our flow rate and our total dynamic head that we calculated in step 3. So those are the parameters we're using to size our pump. And then we are sizing our solar array based on that pump that we've selected. So that's kind of the process. So first it's water demand, and then it's design flow, total dynamic head, then pump selection, and then the solar array sizing based on our pump. So we will start getting into that solar array sizing. But if you had a more specific question on how we're selecting the pump, let me know. You can type it in the chat. I want to make sure I get that clarified. And then we also had a question about the minimum and maximum number of panels, and I'll make sure that we touch on that as well today, and what values that we're using to do that. Okay, so I'm going to go ahead and start with this one and just kind of see where everybody is at today. Okay, so based on the scale, how confident do you feel with the following? So understanding why solar panels don't perform to standard test conditions. These are the specifications manufacturers give us for solar panels. Two, understanding how irradiance and temperature affect the performance. And then using PVGIS to find irradiance and temperature data. This is kind of the first half of Unit 4, which is what we'll focus on today. So I just kind of like to know, how's everybody feeling? Thanks for responding, everyone. I appreciate it. This is helpful for me to know kind of where we are and maybe what topics we want to focus on today. So we've got a good range of confidence levels today. So some of you are pretty confident in all of these. And then others, we have some questions probably. So particularly on maybe understanding why solar panels don't perform to their specifications, and then how irradiance and temperature affect performance. And so these are foundational topics as we get into solar design. Mainly because it just helps us understand why we are going through all the effort to pull irradiance and temperature data for our location in order to design our array. It does seem like an extra step in a lot of ways. Sometimes we think we can just design the array based on those specifications, and we'll see how in most cases that's going to leave you with an array that's not quite big enough. For several different reasons for what you need it to be. Okay, so we'll jump into some more of these polls because those are going to cover a lot of these topics and hopefully just give us some good discussion on the key points here. But again, if at any time you have a specific question about one of these that I'm not including in the polls, again, please raise your hand or type it in the chat. I want to make sure if there's particular areas that you're not feeling confident in right now, or just a question or a challenge you've had in the course. I want to make sure we cover that. Again, the polls that I've created, the questions that I've created are here to help guide the discussion, but if we don't make it through everything I've created for the call, that's fine with me. I'd rather focus on your questions. So please don't feel like you're interrupting. If you have a question, I think that would be really great. So that's just another more encouragement, again, if you have questions. We'll start with this one then. What are standard test conditions?
Uh, Hi, Jessica. I'm not sure, but I think number A, real world operating condition at the project site. This is how we ensure standard test condition.
Yeah, thanks for sharing. So that one's a little bit of a trick answer in there. So standard test conditions are actually the laboratory conditions that are used to rate solar panels. So when they're manufacturing the solar panels and they're testing them, it's kind of like a pump with a pump curve. They do all of the testing and they make this manufacturer pump curve and say this is how it's supposed to perform. Um, Standard test conditions are similar. They do the tests, but they do them at very specific um, conditions. And so standard test conditions are those, it's a set irradiance and a set temperature. So it's typically 1,000 watts per meter squared irradiance and then 25 degrees Celsius for temperature. Um, And so that's what, when you get a solar panel and it has, here's the power and here's the current and all of these um, specifications, those are tested at standard test conditions. And again, that's 1,000 watts per meter squared and 25 degrees Celsius. So very controlled, uniform setting for those specifications. And I'm going through
And
this just because this is, go ahead.
yeah, one more following question, because I cannot imagine how it looks like STC. So is the specific equipment we conduct STC or how it looks like? Can you, if you have picture, you can share, because I could not imagine. I cannot imagine.
That's a good question. So, we as design engineers or implementers, we don't need to worry about creating these standard test conditions, right? This is just kind of background information for how solar panel manufacturers um, get the specifications that they give to us. So it's the solar panel manufacturers who have the labs, or maybe it's a regulatory board that they work with that has the lab that controls all these conditions. Um, it's not something we have to worry about creating or recreating. It's just good for us to understand how they've gotten, when they tell us a solar panel can do 300 watts, it's nice to understand what they mean by that more specifically. Okay, so this can be kind of an open discussion. Anybody who wants to share their thoughts, you can unmute or type it in the chat. But we just talked about standard test conditions. And so why don't solar panels perform to those STC conditions? So if a manufacturer tells us, oh, this panel can do 300 watts, can we believe them? Is that going to be true everywhere? And if not, why not? Zara, please.
It's obvious that the temperature varies during the day and as well as the solar irradiance. So the temperature or the solar irradiance we have at 8 a.m. in the morning is completely different from the one we have at midday. So because of these variations, the standard testing conditions vary when we implement in real time. Thank you.
Mm-hmm. Yeah, that's a great response. So yes, so we said that the standard test conditions that they're using when they make these solar panels or test them is 1,000 watts per meter squared and 25 degrees Celsius. How many of us live at 25 degrees Celsius all the time? probably very few of us. And so we know just from daily life that the sun comes up and it goes down. So in the morning, it's cooler. The radiance, the sunlight that you're experiencing is not as strong. But midday, that's when it's strongest and it's starting to get very warm. And then it's going back down in the evening. And so that alone tells us that our real world conditions are not always the same as what they test our solar panels at. And this is why we have to look at both the irradiance and the temperature when we're designing our solar array. Because if not, we're probably gonna most likely undersize the array based on what the manufacturers of the solar panels is telling us they can do. Any questions about what we've just shared? Yes, Ong, I see your hand up.
Oh, thank you, Jessica. One more thing, what I curious is about, I don't understand what does it mean suitable for ungrounded positive or negative grounded DC system. So can you please explain in brief what does it mean DC system only suitable it mean?
Sorry, can you ask your question one more time? I didn't catch it.
Yeah, it's about I'm curious to understand about DC system. So it mentioned in the nameplate or suitable for on grounded positive or negative grounded DC system. So uh, it means STC only suitable for DC system. So what about AC system? So this is what I'm curious.
Okay, yes. So yes, there's a little bolded text on the picture that I've shown. So I think that's just talking about the solar panel in general, not specifically the standard test conditions. So it's just saying that the solar panel can be used in a, an ungrounded or a positive or negative grounded system. All solar arrays produce DC power. Just by the way they create the power, all photovoltaic systems will be DC power. And so if you added in an AC power source, that'll be kind of separate systems, DC and AC, until you get to your inverter or your combiner. Hopefully that helps. AJ, I see your hand up as well.
Hello, Jessica. Ajay here from India. I have just one question. So, system losses like wiring losses, inverter losses are also affecting to STC. That losses are also considered for STC difference.
So I'm going to ask you to repeat. You said wiring losses, and are we taking those into account?
Inverter or wiring losses, system losses.
So
that also affecting to STC specification in real condition.
Oh, yes. Okay. Yes. Sorry, I understand now. Yes. So system losses and wiring losses, yes, those can also affect the power we're ultimately going to get out of our solar system as well. And so we will typically we'll use the irradiance and temperature data that we find to kind of take into account the difference with STC. And then we usually also apply a derating factor to the solar array to help us make sure we get all of the losses that might be there with wiring losses and other inefficiencies in the system. Yeah, that's a great point. That's another thing that we need to account for when we're designing the power system. All right. We'll kind of keep going through polls, but again, if you have questions about any topics, feel free to speak up. Let's jump ahead just a tad. Okay, so which of these factors has a negative impact on solar power output? Yeah, so a lot of votes for higher temperature. So it's great. A lot of us seem to agree. Higher temperature has a negative impact on our output. For me, when I learned that, it was a little counterintuitive because you think, oh, it's sunnier, it's warmer. That must help my solar panels because they thrive on solar energy. But it is opposite of irradiance, and irradiance is the rays from the sun that are being converted. And so higher irradiance will increase our power output, but a higher temperature actually decreases our power output because it just creates a lot more inefficiency as our solar panels are operating. So irradiance and temperature are the two main factors we're looking at as we prepare to design our solar array, and they have opposite impacts on the power output that we can expect. Any questions about that? Again, this is kind of the foundational, the reason why we're looking into all this, but it's good to understand. So, any questions about why we're looking at irradiance or temperature in so much detail? Yes, Sarah.
Just to elaborate more, Jessica, for a normal person, for non-technical people like you said, if the day is warmer, if it's very hot and sunny, we will assume that we are going to get more production from our solar panels, but it is not the case, you know. Since temperature is inversely related with voltage, the increase in temperature always decreases the voltage we get from the solar panels. As you all know, power is voltage multiplied by current. So if the voltage increases, if the voltage decreases through an increase in temperature, it's definitely the power will decrease. So the power production from a single solar panel or the wider solar field will decrease if the temperature increases. This is because of the inverse relationship between the temperature and voltage. Before I go, I have one question. In the course material, it says that regarding tilt angle, if a project location or an area is located in the northern hemisphere, not about tilt angle actually, the solar panels need to face to the south, and if the area is located in the southern hemisphere, when we install the solar panels, we must face them to the north. What is the reason, Jessica?
Yeah, that's a good question. And so, yes, definitely something that's good to talk about today. So, yes, the recommendation in our course is essentially to face the solar panels towards the equator. So if you're in the northern hemisphere, you face them south, and in the southern hemisphere, you face them north. This has just become kind of general common practice to increase the amount of sunlight your panels are going to get over the course of the day. So as the sun's coming up and going across your array and then coming back down, facing your panels toward the equator should, in most cases, increase just the amount of direct sunlight they're going to get. So there are, in some cases, where that might be different, and you could, there are tools in PVGIS, especially if you're very close to the equator. There are some tools in PVGIS where it will maybe recommend a different direction for you. But in most cases, that's a good general rule. Any other questions about that one? And then I know we'll go back and talk about the tilt angle. AJ.
Uh, when we talk about temperature, so our panel has a cell temperature is 44.9 degree. It's mean our temperature is below that, not more than that. It's mean, no?
When your panels are giving in a specification, they might say 44.9. Usually they are, there's just different specifications that they're going to give. So like, I think it's the normal operating cell temperature. And that is, again, just one of those specifications that they give, and that can give us a baseline for maybe if we're over that
Then
or under that.
what is the best range of temperature for positive output? Temperature range.
Temperature range for like a general project or
General project.
yeah. So again, the test conditions will be like 25 degrees Celsius is kind of their baseline, but it just again it's going to depend on where you are and what your climate's like.
Because in my area in India, the temperature nowadays it's almost 40 degree.
Yeah. So that's hot. And so what you're likely going to see is just that your arrays are not in that season, your arrays are not going to produce quite as much power as they will in the cooler seasons. But when we use something like PVGIS, it should tell us what those temperatures are going to be and let us account for that in our design. So that hopefully that you're designing those solar arrays to overcome some of those high temperature.
One more question. So in our area, we use bifacial panels. So this is has have different temperature range or like that, or more output. Bifacial panels.
Yeah, that's a really good question. I actually do not have experience with the bifacial solar panels. Does anyone else has anyone else used those in a project? If not, I will search for an answer for you, but I don't personally have experience working with those types of panels.
Okay, no. Thank you.
I'll ask around though and see if I know anybody who's used them and what that experience has been with the different temperatures. Great questions. I really appreciate them, guys. It's very helpful. All right, I'm gonna. Oh, sorry. Hop backwards just a tad. I'm gonna hop backwards just a little bit. There we go. Okay. We'll start here and then we'll get into tilt angles as well. Um, all right, so in general, which design approach best ensures year-round reliability? So when we're choosing what data to design for, which approach would help us make sure that we're going to be able to produce water in all seasons? So a lot of votes for worst case month. Um, that's generally what we recommend in the course. So when we say worst case month, we're talking usually about the lowest irradiance month. And so as we've been talking, we know that irradiance, as it drops, our power output drops, and as irradiance increases, our power output increases. So if we design for the month of the year that has the lowest irradiance on average, then we're making sure that our solar array and our water system as a whole has enough power to meet the design demand, even in that lowest irradiance month, which gives us more confidence that it's going to make enough water in those seasons with even more irradiance throughout the year. So in general, that's why we'd recommend designing that way. We've had some votes for dry season as well, and you might have reasons to design maybe specifically for your dry season. Drier seasons are typically going to have a lot of irradiance, so that might just be a higher irradiance month. But dry season might also be very hot depending on where you are, and so that could as we talked about, that could lower your output. So I think just awareness of your situation. If your dry season is very, very hot and you're experiencing very high temperatures, it would be maybe worth a consideration of looking at that data as well. And so there might be, again, I've asked kind of like, when might you choose a different design approach? So I don't know if anybody has experience with this, maybe choosing a different month besides your lowest irradiance to design your system. Are there any questions about why we do this or what this impacts? You know, there are some locations who get very, very heavy rainy seasons. And that in a lot of cases might line up with what is the lowest irradiance. But if it doesn't, then I know some design engineers might choose to use data from their rainy season to design the array or to check it once they have designed it. That's another option as well. You can design your system based on the lowest irradiance month, and then you can kind of make a copy of your spreadsheet and put in the data from dry season or rainy season, winter, just different things. And you can kind of check, okay, what do I think the water production will be in a different season? And you can kind of look at what that is to be able to kind of check your design. All right. If there's any more questions about this or any topic from the course, feel free to raise a hand or use the chat. I know we did have some questions about tilt angle as well. So let me launch this one. Okay, so what is kind of the common rule for setting solar panel tilt? Should be solar panel tilt, not tile. If that confuses you. Everybody who's responded at least is in agreement. That's encouraging. Okay. So yes, what we recommend in the course in our guide is actually equal to latitude with a minimum of 15 degrees. And so again, this is similar to why we might face it north or south, depending on the hemisphere we're in. It's because making it equal to the latitude is what, in general, will give it the most exposure and the most amount of sunlight through the day. And so the exception is that we would recommend a minimum of 15 degrees. When you get much flatter than that, you're going to start seeing a lot more dust accumulate, debris accumulate. It's going to be more difficult to wash off your panels. So we would recommend a minimum of 15 just to help with cleaning and maintenance. So, any questions about that, about the tilt angles or yes, Zarahum. I see your hand up, but I don't hear you yet. You're welcome to share.
Okay. Okay. Sorry. I was talking while muted.
I do it all the time.
Yeah. Just to elaborate on the tilt angle, the minimum requirement, like you said, is 15 degrees. But we take this 15 degrees if the latitude of our area is less than 15 degrees. For example, if we are living or if our project area is located in a latitude which is less than 15 degrees, we take the minimum requirement, which is 15 degrees. Otherwise, we take the tilt angle equal to the latitude of the area. Thank you very much.
Yes, yes, that's a good clarification. So if you're particularly if you're very close to the equator and your latitude is less than 15, then that's when we recommend that your tilt angle would be 15. So yes, if you are very close to the equator, then likely a lot of your projects, if not all of them, will be at that 15-degree mark. So, but if you're farther away from the equator, we'd recommend making it whatever your latitude is. Okay, so we did this one today. If you've joined us in maybe a little bit late, we did this one earlier. So general recommendation again is if you're in the northern hemisphere, you face your panel south, and then southern hemisphere, you face them north. Essentially, you're facing your array towards the equator to increase the amount of sunlight it's going to get during the day. I'm going to skip ahead just a little bit. Are there any questions about using PVGIS? Has anyone had difficulty getting to the website, entering the right data, getting your data back? Any issues? or just any questions really about PVGIS, irradiance, temperature. We've got about 5 minutes left today, so I have a few more quick slides we can go through. But again, if you have questions or things you want to talk about today, please let me know. It'd be a great thing to use our last 5 minutes for, if anyone has specific things they'd like to talk about. Okay. Well, I think I accidentally put the answer on the screen for this one. So we could just talk through it. But true or false, we must design our solar array by calculating the power output for every hour of sunlight because of the significant fluctuations. That's a very long statement, but it is true, as the slide says. And so, again, we started our conversation like this at the beginning of the day, talking about how standard test conditions, those nice laboratory conditions that our solar panel manufacturers use when they're giving us specifications, we don't see that in the real world. Sometimes because of climate and weather, but also just because of daily fluctuations. The sun rises in the morning, it sets in the evening. That changes the irradiance, the temperature, each hour of the day, which is going to change our power output for each hour of the day. And so if you've already finished Unit 4, you know that we're doing a lot of very repetitive calculations, and this is why. We have to look at every hour of the day so that we can see what our system's actually going to be doing as that sun rises and sets. So hopefully this has been a good setup for why we do all the repetitive calculations. If you've completed Unit 4, you've seen it. If you're still working towards it, then hopefully this gives you an understanding of why we're doing it over and over and over throughout the day. So next week, we'll start talking a little bit more about the actual array and figuring out minimum and maximum number of panels and putting it all together. So just for today, again, we've talked about irradiance and temperature and the importance of using location-specific data. Are there any other questions about that or about Unit 4? We did have in the beginning of the call a question about determining the minimum and the maximum number of panels and how we're using average values to kind of figure out those. So we can talk more about that next week as well, because we'll get into that. But yes, so when we're trying to estimate the minimum or the maximum number of panels we might have, just keep in mind that's all an estimate. So we can use maybe our average values to get that estimate to start off with, and then we'll see more of the details as we move through our designs. And we can, again, talk more in detail next week about that. Ahmed, I see your hand up.
Yes, thank you. Sorry, just quickly, when you were mentioning estimating number of panels, I noticed in the materials, if you estimate 8.8, instead of saying use 9, it usually goes to use 8 panels instead. So I was thinking, what was the thinking behind that? Thank you.
So it depends. I have to make sure I get my thinking right. It depends on whether we're estimating the minimum or the maximum for that. And so when we're trying to look at panels in series, we need to make sure that we don't exceed our upper limit. So our pump might have an upper limit of 300 volts that it can take. So if we're estimating an upper limit and we get 8.8 and we bump it to 9, we might exceed that limit. So that's the reason. When we're estimating the lower limit, though, we'll do the opposite again, so we don't go under the voltage that we need to hit. So yeah, that's a great question. It just depends on whether we're doing upper or lower limits. And again, they're estimates. So if you were to design it with 9 instead of 8, and you continue to move through your calculations, you'll look and you'll see, oh, did my voltage go over the limit or not? And you can check it that way as well. So again, all estimates, but generally that'll help get you a good starting point. Okay, so again, next week we'll move into the final week of the course. So you'll have time to finish Unit 4 or kind of get caught up if you need to. And then there's a final exam that you'll take. There is still some people are doing well with the final exam. Some people are still having issues with the grading. So apologies if you have trouble. Just message me on WhatsApp or the course platform if your final exam grade doesn't go through. I would love to help you with that. And again, if there's any questions between now and our next call, there's the Q&A forum on the course or the WhatsApp discussion group. Feel free to drop them in there. So we're at time. So if you need to hop off, please do. I can have just a few more minutes if there are any. Were there any final questions that didn't get asked? Anybody have one that is lagging? Okay, great. Well, thank you all so much. I know it's a smaller group today, but I really appreciate all of you taking the time to be here. And thank you for sharing your questions and sharing your experience. That's very helpful on these calls. So that's what we like to see. So I hope that you guys are enjoying the course and that you enjoy the last week. Again, challenges or questions, please just reach out. We want to make sure everybody finishes the course. I know all of you can do it. Some of you already have, so congrats to those who have. So we will hopefully see you all next week at the same time. Thanks, everyone.
Thank you very much. Ciao, Jessica.
Thanks.
Thank you very
Yes.
much, Jessica.
Thanks, Jessica. Thank you.
Thank you. Have a good weekend.
Same.
You too.
Very also.